Hello everyone, my name is Ermias. Today I'm going to give explanation about the Linux booting system and the process behind the scene when we boot the Linux system. Here I have some picture which give you some overview about the process and the process flow of the Linux booting system. Here we have the power button. Now let's go and turn off this machine, and we have this the power button. When I click this stop, and I will turn on again, and I will explain the process behind the scene, what will happen when we boot the machine. Here, as you can see, I click on this power button, and this power button, by the help of signal, it will go and initiate this BIOS or UEFI, which BIOS stand for Basic Input Output System. UEFI stand for Unified Extensible Firmware Interface. This load go and detect the readiness of hardware such as mouse, keyboard, and monitor for the hard drive. If it is not ready, this post power on self-test, it is called power on self-test, will give the signal back, the error report to the user who is trying to reboot the system. Now, this, after it detects the machine, it will do certain task after that. If the machine is ready, this will this BIOS perform certain tasks, such as it will locate the operating system kernel to the disk, and also it will load the kernel to the memory, and it will start the kernel code, which is the grab. This grab is called the kernel code. I will show this one and all the process and all the file responsible to execute all the process and to make the Linux system to go live and available for the user. I will give detailed explanation about each file. So this graph contains certain script which help and transit this UEFI, which is in the modern system. Most of the Linux use this unified extensible firmware interface, and it transits this system. This is actually it is a piece of software. It transits this one to the actual operating system, which is the kernel. Then after that, the kernel finish the process. Okay, then from that, the kernel also this graph, the kernel, after taking the transition from this graph, it will go and start all the module required for the drivers, for the hardware connected to our Linux system by the help of the systemd, which is initr. Initr means, I will show you all these files which I'm talking now. Initr means init ROM disk, which contain information about the module which is required to be started for the Linux system to be ready for use. And this is the operating system, which is the kernel. And the kernel go and start all the module, and our machine go live. And let's turn on this machine, and I will explain all the process going on behind the scene. Actually, this takes the process takes a couple of seconds, but this in a couple of seconds, all the process which we are talking on this graph on this diagram happen. I will log into my system. Now we'll go to the boots directory. That is where the file located. And I will list the content, and I will show you the file exists in this one. Here, I'll try to give the explanation about this graph. This graph help the UEFI or the BIOS to transit the process, the startup process to the actual uh, to, to the actual operating system, which is the kernel. And also this graph start the kernel, and the kernel takes over the computer resources, initiate all the process background and the background process and the services. And the kernel also decompress itself into the memories and check the hardware and the loads, drivers, and the other kernel module, which is located inside. And this is step number 6 and 7. And this kernel use the information which in its RD, this one, and I was saying in this graph there is a piece of script, right? Let's go and see what is inside this graph folder. That is the content. Now here we have this file called graph.cfg. This contains the piece of script which help the BIOS to transit the process to the actual operating system, which is the kernel. Now let's see the content inside this graph.cfg. It needs the privilege permission, so I have to use sudo to give my password. Here we go. Now, as it is visible, this is a script which help the BIOS to transit the process to the actual operating system, which is the kernel. I will go and clear this one. Now, I will give some brief explanation about this init.rd, this file. Now, this is our operating system, the kernel, which take the process, grab this, the file inside this graph, transfer the process from BIOS to this one. And this is the empty operating system, which is empty kernel. And this empty kernel is linked with this init.rd, which is init ROM disk. This init ROM disk contains information about the module, and this the kernel decompress itself into memory and check the hardware and load the device drivers and the other kernel modules. The module is located inside lib or lib directory. These initRDs contain information about which module need to be started by this kernel. After this kernel go and start all the required drivers and the modules, this system map will map all started module to all hardware connected to our Linux system. I hope this is clear. Now we will see the content of this initRD. This contain the mapping file. So we'll go and see. I'll show you the content. I know it is a kind of complicated process to give like brief overview about the booting system. That's which I think I'm missing. Let's use the latest one. Okay, I made this mistake. Here we go. This system.map contains the file which help the kernel or the operating system to map all the started module and driver, all the loaded drivers and started module to the available hardware. I hope this is clear, and let's clear this one. I will load again this one, and I will show you the directory where this module is located. Let's assume that we are going to start networking one module for the network device. The module is located inside the lib directory cd. Inside this we have the kernel here. In this kernel we have all the available modules, but this is not located in the hard disk, not located in the hard drive. Now we are in lib modules directory, right? In lib directories we have another directory called modules. Inside that we have the kernel. This is the empty kernel without the module, this one. And this is the kernel or the operating system with the full of module. But why this is empty and why this is contain all the module? Because this located on the hard drive, and for the efficiency of the hard drive, it is designed this way, and this contain information about this one, about this directory and the content of it. This init RD, init ROM disk, init ROM disk contain information about the kernel and the module inside this one. So it will, when the process transits from BIOS or UEFI by the help of grub, and the kernel take over the process to make the Linux system to go live. This provide information for this one, and this empty kernel come to this directory and load all drivers required for our hardware to go live, and also the load to start all the module required for the hardware. Let's go to this directory, which is the latest kernel version. Let's list. We have here directory called kernel. And in this directory, we have drivers. Earlier, I was saying the kernel will load all the drivers and the module. So the drivers is located, the drivers and the module located in this directory. So let's go to this directory. Okay, list. Here is all the directory contain different type of drivers and modules. Earlier, I was assuming let's go and start module and drivers, load drivers for networking, right? Let's go to the networking folder and let's see the content. Here we have lots of networking drivers and the modules. I will give again one more explanation. We click the power button, it will start the system. It will give the signal to the BIOS. The BIOS detect if the hardware device is ready for the hard drive. If it is ready, it will pass the process to the bootloader, which is the grub. The grub contains a piece of script. If the hardware is not ready, this post will run and provide the information about the error. Post stands for power on self-test, and this BIOS or UEFI is a piece of software. Then this grub make the transit of BIOS or UEFI to the actual operating system. Then the actual operating system takes over the process and will go and start and load all the drivers needed for Linux system to go live. On this terminal, this process is done by the help of this file. We have the graph here, which contains a piece of script and make the transit from BIOS or UEFI to the operating system, which is the kernel. The kernel, this one, will go and will come in this directory and load one of these files. All required file available in this module by the help of this one. This init.rd contain information about this module, and it will direct the kernel to come here after this module. For example, if Thunderbolt start or if wireless start, system map will map this process to the hardware. This is what the booting process look like. If we want to block any of this module, we have to go and blacklist. And I will show you how to blacklist the module. If we don't want the module to be started, it is possible to make blacklist, which block the module. And when operating system come here, try to start the module, it will not be started. Let's go to home directory. Let's go to etc. Let's go to etc directory and just in this directory we have file called blacklist.config. If you want to blacklist any of the file, any of the module, sorry, not the file, any of the module, we can go one of this file. For example, if vi blacklist.conf, it contains all the blacklisted module. If we don't want the module to be started, we can come here and add the module here. Now I don't want to blacklist any module, so I will quit and leave this editor. And this is all about the Linux booting system. And you can also make your own research online to more deeply understand how all these things work. Specifically, if like you go and like search how the system works, system design, they will give you clear explanation about this one. Thank you for watching. That is all for today, and see you next time.